What is an emergency power supply system? There are basically two kinds. One is battery powered. That's dealt with in NFPA 111. We're going to talk about the engine driven system. That's dealt with in NFPA 110. It's designated as an EPSS, which stands for Emergency Power Supply System. An engine-driven emergency power supply system consists of four main parts. First is the automatic transfer switch. Then there's the control panel or control system, often mounted on the generator set itself. Then there's the generator. That's the part that makes electricity by converting the torque created by the engine into electrical power. And then, of course, there is the engine. The automatic transfer switch is the main control for the system. It continuously monitors both utility power and generator power. When the utility voltage drops down to about 80%, it will initiate a process that starts the generator and transfers the load from utility power over to available generator power. Then it continues to monitor the utility. When the utility voltage rises to about 90%, it will initiate a process to transfer back to utility and shut the generator down, making ready for the next operation. The transfer switch has four time delays. It has a time delay on start, which allows the system to override nuisance outages. This usually is set for a couple of seconds. It then has a time delay on transfer. That is usually set for 3 or 4 seconds, up to 10 seconds, and that allows the oil to get up in the engine, for the engine to warm up just a little bit before assuming the load. After utility power picks back up to around 90%, then the transfer switch will go into its time delay for retransfer. This can be up to 30 minutes, and that allows the utility to stabilize after coming back on. Once the utility has been stable for a preset time delay, it will transfer the load back to the utility and initiate a sequence to shut the generator down. It also has an automatic exercise system built into it, which will run the machine for a period of time, usually every week. Here's a picture of two typical automatic transfer switches. They're often found in the regular distribution lineup down in the electrical room. Sometimes they're not. Sometimes they're in the generator room, and sometimes they're even outside of the building. But this is basically what they look like. The generator control panel is a device normally mounted on the generator itself. It could be mounted on the wall near the generator, or it could be in the electrical distribution lineup down in the electrical room. Now, this provides automatic engine starting after it receives the signal from the automatic transfer switch. It monitors the engine and generator functions, such as oil pressure, engine temperature, engine speed, and voltage output, as well as sometimes current output. It provides signals to the remote annunciator. Now here's a picture of two typical generator control panels mounted on the generators themselves. The one on the left is a Generac panel. It's an older style. The one on the right is a late style Onan controller. There are many different manufacturers of controllers, and they look different, but they all have basically the same function. The generator is attached directly to the engine. It converts the torque from the engine into electrical power. It does this with a big electromagnet that spins at the same speed of the engine to induce an electrical field in the stationary windings. The voltage produced is controlled by a voltage regulator adjusted to match the utility voltage that your equipment requires. The engine governor controls the generator speed and therefore the generator frequency. In North America, we use 60 cycles. Now here's a picture of just a generator end. You'll see the cooling fins. Air has to pass over the generator because as it creates electricity, it gets hot. The engine is directly connected to the generator. It converts the energy from the fuel source into heat and torque. Torque is the twisting motion that the engine creates. Now, this can use a variety of fuels, but typically we like to use natural gas, diesel, or LPG. This is a photo of a little Cummins four-cylinder diesel engine. The engine could be a John Deere, could be a Caterpillar, could be a Ford, could be a Chevrolet. Depends on what's available and the size of the generator to be built. All of the items I've mentioned are themselves systems dependent upon many subsystems and individual component parts in order to function. These intricate systems, along with fuel supply systems, batteries, battery chargers, emergency lights, air handling, and exhaust systems, come together to supply automatic emergency electrical power. All information expressed by Standby Power Solutions, LLC, or its officers is strictly the opinion of Standby Power Solutions, LLC. Standby Power Solutions, LLC disclaims any liability for any personal injury, property, or other damages of any nature whatsoever, whether special, indirect, consequential, or compensatory, directly or indirectly resulting from the publication, use of, or reliance on this website or any information derived thereof. Standby Power Solutions, LLC also makes no guarantee or warranty as to the accuracy or completeness of any information contained herein. Anyone using this website should rely on his or her own independent judgment, or, as appropriate, seek the advice of a competent professional in determining the exercise of reasonable care in any given circumstance. All rights reserved. Do not reproduce without express written permission.